Hey everybody, welcome back. Today we're going to be tackling a real common problem. How do you give multiple users access to an LLM without sharing your actual API keys? So with Agent Gateway, you can issue virtual API keys and each user can get their own, really can get their own key with their own token budget. And your real provider key stays hidden behind the gateway. So what we're going to do in this quick demo is we're going to build this from scratch. Or we're going to deploy a kind cluster, agent gateway, two users with independent daily budgets, and then we'll test everything live. So really, let's get into it. So I have this script you could follow, just step-by-step guide. The first thing we're going to do is create our Kubernetes cluster. So we're going to use kind inside of Docker, so everything runs locally itself, kind of one command, and you've got to kind of have your cluster set up. There's a couple other tools you need installed: kind, kubectl, Helm, JQ, and curl. And of course, you're going to need your OpenAPI key. And you can just get that from platform.openai.com. So first thing we're going to do is initiate this command create or kind create cluster, and we're going to give it a name, AGW series. And on the right hand side, what you'll be able to see is kind of what we're building out. And the first thing we're building out is that Kubernetes cluster. So once the Kubernetes cluster is deployed, and all you have to do is in this step-by-step guide is kind of press enter and it'll guide you through it. We need to install the Gateway API CRDs. And this gives us resources like Gateway and HTTP route, which is how we define our listeners and our routing rules. So Agent Gateway is built on top of the Gateway APIs. So it is pre-required to have this installed. So now that it's installed, we have the CRDs installed. Now we need to install the Agent Gateway CRDs and then add the um, custom resources like Agent Gateway backend and Agent Gateway policies. And that's where this LLM specific configuration lives. So in the next steps, we have those CRDs deployed. Then we're going to be installing the control plane itself, and this deploys the control plane and the proxy. The controller watches for the configuration changes, and the proxy handles the actual traffic itself. So once that is complete, let's just issue a command to verify everything inside our deployment. And this takes like a couple seconds to deploy. So as you can see here on the right hand side, we have our Gateway API CRDs. We have our Agent Gateway version 1.1 controller and proxy deployed. We're just going to verify that everything is working. We see our Agent Gateway is running. So now the first thing we need to do is create a gateway resources. This is our entry point. So it listens on port 80 in this example for all the traffic and accepts routes for all the namespaces. Think of it as really the front door. So once we have this deployed perfectly, the output we see here was created. What we want to do is create a secret itself. So this is the real OpenAI API key. It's stored as a Kubernetes secret. Agent Gateway uses it when it makes outbound requests to OpenAI. So users will never see this key. They never touch it. It just stays inside the cluster. And now here's where kind of the fun, interesting part is. We're going to be creating two secrets, one for Alice and one for Bob. And they are going to have two virtual keys itself. And you'll notice that, the specific labels that we use in here, like API key groups and LLM users in this case, because each user is going to have their own key, right? So Alice will have SK Alice and Bob will have SK Bob as an example. And these are just tokens that will be included in all their requests. So now that the we have a lock on the front door, we have to create these agent gateway policies itself. And the agent gateway policies targets the gateway and enforces API with key authentication in strict mode, right? And what that means is that every request must include a valid bearer token. So if the key doesn't match one of our virtual keys, it's a 401, right? No exceptions itself. So let's enable that. So there we go. We can see here everything's being created. Then the next thing we want to do is for token budgets, because we're testing this out in OSS. Enterprise already has this built in, but in OSS, for token budgets, we need two things. We need Redis for storing counters and the Envoy rate limit server for enforcing limiting, right? The config map in here defines our budget, 100K. So you can take a look at the configs that we have here per user, and the rate limiting server reads this config and checks on every request. So let's apply this. And then we're going to apply the token budget policy for this next. So in the policy itself ties this all together. So it tells Agent Gateway to check the rate limit server on every request. And it's using the X user ID. So as you can see here. And this header identifies who is making the call. And it's a cell expression that pulls the user ID from the header. So the unit is set to tokens, not requests. So we're really tracking actual token consumptions, not just call counts, which is kind of important to know. And you can set other units and you can kind of play around with this however you want. So now that we have those users created, we have the virtual keys for Bob and Alice. We need to create our backend to connect to OpenAI. And in this case, I'm just going to use GPT-5o-mini, and we're going to connect this via our secrets provider. So, and finally is the route. So this is the HTTP route that we need to configure. And this matches any requests that goes to /OpenAI. So if we're querying our gateway, we're sending it to /OpenAI, and it's going to send it to our backend. So the full circle really is that the client hits /OpenAI, the gateway checks the API key, checks the budget token, and if everything passes, it routes to OpenAI itself. So, and we could do a last check. We can do get kubectl get gateway HTTP backend routes, and ensure that all the services, all the configurations are deployed and ready to go. And finally, the next step is to test this out. So with all these steps complete, you can actually take a look at all the commands here. It's about 12 steps to validate, verify, and install everything. I'll have everything posted in the descriptions below and the Git repo with the code, so you can just run this yourself and test it out. What we want to do is then test this environment out. So I created a nice little test just to make this easy. So for the first test, what we're going to do, well, first we have to ensure we have the port forward 80 connected, so we can connect to our Kubernetes environment. And the first test we're going to do on the left-hand side, you see we have user Alice. She's got a valid virtual key, so this should go straight forward. We're going to send a post to /OpenAI with her bearer token and her user ID. And let's execute that. And we're going to see that, we get a status of HTTP 200. We get the model. It took 17 tokens, and we get the context back. So Alice was authenticated with that specific model within a request. So let's try Bob once again. Right? Different user, different key, different user ID, completely independent budget. We're going to send that request one more time. And of course, it's successful. We get a 200 OK. Bob is authenticated. He used 17 tokens as well. and we got the response hello from GPT-5.4 itself. Now let's take a look at example if we have an invalid API key, right, or an invalid key. This is a Malroy, an attacker, and with a key we never issued, so he makes up a key. Right away, when we send the request, we're going to get a 401 response because that key is invalid, and we have our gateway set up in strict mode, so it's rejected and no response is being made. We're enforcing, that authenticate, or we're enforcing authentication before anything happens, right? And then we can send another test, a quick one, just an anonymous user with no key at all. And we're going to get the same response. Should be blocked. There's no key. We get a 401 response and API authentication failure itself. So missing key was rejected by the gateway. So really, it's that simple to set this entire environment up. A couple steps to deploy this inside of a kind cluster, or you could take this and deploy it in your Kubernetes environment itself. But we had two passes, of course, two blocks. The valid keys worked as expected, and the invalid keys or malicious attacks do not work itself. And each user, of course, has independent tracking, and the real API key is never exposed, right? So, that's really virtual keys with Agent Gateway. Just to recap, we issued virtual API keys for 2 users. We set up per user daily tokens of a budget of 100,000 tokens each. We routed everything through the gateway to OpenAI and verified that invalid and missing keys get blocked at the door, all without ever exposing that real API key provider, which is super critical, especially now, as you might have heard on the news, some of the attacks or some of the API key exposures that we're kind of seeing in the news happening. So I really hope you enjoyed this video. If you have any questions, drop them in the comments. I try to read every single one of them. And if there's a topic or feature you'd like to see, or how-to video or how-to guides, how to set up scripts, let me know. I'm always looking for great ideas. And if this was helpful, make sure to smash that like button, hit subscribe, and don't miss the next one. All right. And head over, please, to our GitHub page and give Agent Gateway a star. It really helps the project and the community itself. So links will be in the descriptions, and we'll see you in the next one.